When you come from the traditional world of web applications and you're used to the HTTP request response cycle, the whole concept of message queues, like RabbitMQ, can seem confusing and not a little intimidating. The concepts of publishers, consumers, bindings, exchanges, queues, where do you even start? If you want to learn how to implement event-driven architecture into Spring Boot applications and you haven't used RabbitMQ before, then this video is for you. I will walk you through the basics of RabbitMQ in a way that actually makes sense related to a real-world use case, using easy-to-understand, beginner-friendly code. So by the end of this video, all of these currently confusing, jumbled-up concepts will line up neatly in your head, and you will have a better understanding of the basics of RabbitMQ and how to incorporate it into your Spring Boot applications. So let's get on with it. So what is RabbitMQ? Well, RabbitMQ is a program that implements the AMQP, or the Advanced Message Queuing Protocol. And the AMQP is a messaging protocol that enables client applications to communicate with messaging middleware brokers. So RabbitMQ is essentially a messaging broker. Okay, so what does that mean? Well, I don't want to get too deep into that at this stage. For now, it might be helpful to think of a message broker as doing a similar job to a post office. So it receives messages and makes sure that they are delivered to the right destination. Now in this context, the destination is a queue within RabbitMQ. Now I don't want you to worry too much about that or the terminology that you can see in these documents at this time. These things will become clearer as we work through this video. For now, to make sense of the Advanced Message Queuing Protocol, I think it will be useful to compare it with another protocol that you might be a little bit more familiar with. And that is the Hypertext Transfer Protocol, or HTTP, as it's commonly known. I'm guessing that you clicked on this video because you want to find out what the deal is with RabbitMQ, and because you have some experience of building web applications, probably using Spring Boot, and you're already familiar with the HTTP request response cycle. So let's start there, and we'll move on to the Advanced Message Queuing Protocol after we've looked at that, and we can compare and contrast the two protocols. So we're going to explore this typical HTTP request response scenario. So if you imagine we have a user who's browsing an e-commerce web application, so some kind of storefront, and when this user puts items into her basket and clicks buy, the app needs to inform a warehouse management system of that transaction. So how does that happen in the world of HTTP? Well, the storefront, which in HTTP speak is known as the client, sends an HTTP request to the warehouse management system. So this is a request. And the warehouse management system in the HTTP world is known as the server. So the client sends an HTTP request to the server. The request will probably have within its body, it will have the details of the order from the storefront, probably in JSON format. That will land on the server. The server will process that order, and it will send a response back to the client saying, yes, I've dealt with that, or there was some kind of problem with it. So that is the response. So that, at a very basic level, is the HTTP request response cycle. Now, for this to work, the client needs to know how to contact the server. So it needs to know its address, and it needs to know how its API works. And also, both apps, the client and the server, need to be up and running at the same time. Otherwise, the cycle breaks down because the communication between these two parts of the system is synchronous. So those things, the fact that the client and server need to have knowledge of each other, and the fact that the communication is synchronous, are hallmarks of a closely coupled system. And that's essentially what the HTTP request response cycle is. It's part of a closely coupled system. So let's make it clear that here we're dealing with the HTTP request response cycle. And the two things that are hallmarks of that are that it is closely coupled and communication is synchronous. If I can spell synchronous. There we go. Now let's examine this same scenario in the event-driven world with RabbitMQ. So here we have the same user, same storefront, and the same warehouse management system. But the big difference in the event-driven world is that the storefront and the warehouse management system are not directly connected. So whereas in HTTP we would have a direct request being sent to the warehouse management system, in the event-driven world that doesn't happen. Instead, in between the storefront and the warehouse management system, there is a message broker middleware. Now you probably remember that from the RabbitMQ docs that were on the screen at the outset. So to make that clear, let's add a box in the middle and we'll label it RabbitMQ to make it obvious that that's what that is. So that is the messaging broker middleware. Now, if I just scroll back up for a moment, the web application protocol that we're all used to is HTTP, Hypertext Transfer Protocol. Now, a protocol in its widest sense is simply a set of rules to define behavior, and HTTP defines how different parts of a network should communicate with each other. Well, RabbitMQ is a program that implements a different protocol, the Advanced Message Queuing Protocol, which we've already seen. And that is essentially another protocol that lays down the rules for how the elements of this system should communicate with each other. But this communication is done by way of the message broker middleware. So let's explore what that means in practice. So when a user clicks the same buy button, instead of sending a request directly to the warehouse management system, our storefront publishes an event to RabbitMQ. Let's draw that in here. It will publish an event. So you remember in the HTTP world, our storefront was called a client. Well, in the event-driven world, our storefront is called a publisher. And on the other side of RabbitMQ, we have an entirely separate process. Our warehouse management system will itself connect to RabbitMQ, and our warehouse management system is another client application, and it will consume any events that have been published to the queue within RabbitMQ. So in the event-driven world, our warehouse management system is known as a consumer. And it connects to RabbitMQ and it consumes events. Now, something super important to understand at this stage is that the publisher knows nothing about the consumer, and the consumer knows nothing about the publisher. The two services are not in any way directly connected, and this is a hallmark of an event-driven system. Its services are decoupled and communication is asynchronous. So let's add these down here as our hallmarks: decoupled and asynchronous. And remember, the protocol that we're dealing with here is Advanced Message Queuing Protocol. Now, because the different parts of this system are decoupled and communication is asynchronous, as far as in-the-moment communication is concerned, the warehouse management system being down doesn't prevent orders being processed from the storefront. And the storefront being down doesn't prevent the warehouse management system processing any orders that are already in the system. Those things are one of the main benefits, really, of event-driven architecture. Now, clearly, there's a lot going on inside this RabbitMQ box. But for now, don't worry about that. Let's just start implementing this structure in code. And when you have a feel for the practicalities, we can look in a bit more detail at what goes on in this RabbitMQ box. So what are we going to build? Well, we're going to build a publisher application representing the storefront and a consumer application representing the warehouse management system. And we're going to build a RabbitMQ messaging broker. So the publisher and the consumer will be separate Spring Boot applications, and RabbitMQ will run in a local Docker container. So those are essentially the prerequisites for the rest of this video. You need to have an appreciation of how to build Spring Boot applications, and you have to have a basic understanding of running Docker containers locally. Okay, that's enough theory. Let's get on to the code. Okay, the first thing we're going to do is get RabbitMQ running locally on our machine. There's a couple of ways you can do that. If we just have a look here, there's an installing RabbitMQ page in the documentation. So you can either use the community Docker image, or you can actually download the RabbitMQ server to run it locally on your machine. I've never done this. I've always used the Docker image. So that's what I'm going to do now. If you prefer to download the application and run it locally that way, then I'm assuming that will be absolutely fine. You will need access to the local user interface. That's part of the Docker image, because as you can see, it has this management tag on it. You will need that. So if you're going to download it, make sure that that's available to you. Okay, so moving on, assuming we're going to use the Docker image. If you don't already have Docker installed on your machine, then go here to the Docker desktop page, and you can download Docker desktop for whatever OS you've got. If you're on a Mac, make sure you get the one that's the appropriate download for the chip in your Mac. Okay, so once you've got Docker installed on your machine, we'll open up a terminal, and then we'll run this command here, which I'm just going to alter this slightly, but I'm going to copy it across. But before I run it, I'm going to just make a very small change. I don't want it to run interactively. I want it to run detached, because I'm not going to be doing anything with this Docker container. I just want it to run. I want Rabbit to run in the background. So I'm going to run the container detached. This isn't a Docker tutorial, but I'm just going to run through what these commands do. So the -d option runs the container in detached mode, so that it's just in the background. The rm option, when we stop the container, well, Docker will actually remove the container. So that's a handy thing to have. We've added a name to it, so that makes it easy to access the container after it's running. And we're defining two lots of ports. So 5672 is the port within the container, and the external port in my local machine relating to actually running RabbitMQ. And the second port that we're defining here, 15672, is the one on which the local UI will run. So once you've got the container running, you can open up localhost port 15672, and that will give you access to the local user interface for RabbitMQ. So we'll take a look at that in a moment. And this is just the image that we're going to pull. So if I run that command, so it's now pulling that RabbitMQ for image from Docker Hub, which will just take a few moments. Okay, so because I ran it in detached mode, it looks like nothing has happened. So we'll need to run Docker PS, and we can see, if I just make that full screen, it's easier to read. We can see that we've got a container with that ID running the image that we've just pulled, and the container is called RabbitMQ, which is the name that we gave to it here. And you can see the different ports identified in there. So we can see that the container is running. If I now go to the browser and open up localhost, there we are, 15672, there we go. That is the local user interface for your local Rabbit instance. So we have RabbitMQ running locally. We'll move on to the next stage, which is to create a Spring Boot app for our publisher application. So effectively the storefront. As I mentioned a few minutes ago, our publisher app, which represents the e-commerce storefront, is going to be a Spring Boot web application. So to get it up and running, let's use Spring Initializer. Now you can see that I've filled in various options in the form already. It's going to be a Java project using version 17 and packaged as a jar, and going to be using Maven as the build tool and Spring Boot version 3.4.4. So the dependencies that we're going to need are, since we're using Rabbit, we'll need Spring for RabbitMQ. We don't need the Streams version, just the basic Spring for RabbitMQ will be fine for this project. We need Spring Web, because we're going to include a very basic REST controller that will enable us to send events or messages to the broker. And we're going to use Lombok because, well, just because I'm lazy. Okay, we've set up all of the options in the form. We've chosen the dependencies. All we need to do now is click generate and we'll download the project files. Okay, I've unzipped the project files that were downloaded from Spring Initializer and I've opened the project in IntelliJ. You can use whichever editor or IDE you're comfortable with. It doesn't have to be IntelliJ. Now, the structure of the project that you can see here should look familiar to you if you've used a Spring Boot before. Okay, so the app that we're going to build will be a Rabbit publisher. If you think back to the intro and the drawings that I had on the screen there, you remember that the publisher is the e-commerce storefront. Now, we're not going to build an actual storefront here. This will simply be an app that sends messages to the broker, but you can think of it as a representation of that storefront. Now, in the HTTP world, this would be the client, and it would send a post request direct to the server or the warehouse management system. Now, in this context, in the AMQP Rabbit world, this app that we're building here is a publisher, and it will send messages to the message broker. So the first thing we need to do is to create an order model. This will define the shape of the data that we will send as a payload in the message. So let's add a new package that we'll just call model, and in there we'll add a new class that we'll just call order. Now this is a fairly basic app and it probably doesn't need to be organized into different packages, but on the assumption that this might grow into something more functional, let's start out with organizational best practices in mind. So we've got a model package and we've created our order class in there. So I'm going to leverage Lombok that we initially installed as a dependency when we set up the project. So I'll be using annotations here to reduce our boilerplate code. So I'm going to use the @data annotation to give us getters and setters, and I'll also use the noargs constructor and an allargs constructor, and also a toString annotation so that we can simply log the order object later on in the process so that we can see what's going on. Right, so our order object is going to have an ID, which will be a string, and a product description, which is also going to be a string, and a date. So we'll import that date class. So that's it for our order object. Now we need to define some configuration values for RabbitMQ. These will represent the bare minimum that you need to connect to our Rabbit instance. And we're going to be defining the queue, the format that the message payload will take, and a Rabbit template. I'll talk a little bit more about each of these things as we add them to the config file. First off, we're going to need a config package. So let's create one of those. And in there, we'll need a new class, which is simply called RabbitMQ config. I'm going to, before we do anything else, annotate that with a configuration annotation so that the beans that we define in here will be made available in the application context by Spring. First thing we need to do is define the queue. So we'll have a public method that returns a queue, and this is the queue library from the Spring Framework AMQP core. If we take a quick look at the pom.xml, here we can see we've got Spring Boot Starter AMQP defined as a dependency in our POM. That's because it was included as a dependency in Spring Initializer when we created this project. So that gives us access to the Spring Framework AMQP core library. So that's where that queue object comes from. And we can just call this method order queue. and this will simply return a new queue. And this is where we give the queue whatever name we want it to have. Let's just call it order queue. We need to remember that this needs to be a string bean. Okay, I think actually before we move on, it's worth extracting this as a constant that we will just call queue, because that we might be using that elsewhere in this project a little bit later on. So next we need another bean that will define the message converter that we're going to use. And again, this comes from the AMQP library. So we'll just call this method message converter. And this is going to return a Jackson to JSON message converter. So we're going to send our messages with a JSON payload. So this method here that returns this Jackson to JSON message converter object will take care of converting our native Java object into JSON so that it can be passed into the message. And the last thing we need to define in this class is a Rabbit template, which again is going to be a bean. And we're actually going to return something called an AMQP template. We'll just call the method template. And this takes a connection factory, which is another AMQP library object. So we can just call that connection factory. So we're going to define in here a Rabbit template, which we'll just call template. So we just need to import that class. And this template needs to take the connection factory that we passed in as a parameter into this method. Now this connection factory gets passed in by Spring auto-magically behind the scenes, if you're wondering where that comes from. So now we've defined our template object, we can set the message converter that we want it to have by using the setMessageConverter method on the template object. And we just pass it the message converter that we've defined in the previous method. So now we've fully defined our template, we can just return it. Okay, that's all of the config that we need for this simplest kind of Rabbit publisher. Next, we need a class that will publish an order to RabbitMQ. So we'll create a service package. And inside there, we'll create an order publisher class. And we want to annotate this with the service annotation. And we need to inject a Rabbit template. So let's do that first. And we can use Lombox at required args constructor here. So now we need to define a method that will send an order to the queue. This doesn't return anything, and we can just call it send order, and it will take as a parameter the product as a string. Now within this method, we're going to build the order that's relating to that product and send the complete order to Rabbit. So we will instantiate a new order. So we'll import that class. So that's the model that we defined earlier on. We'll set its ID to just a random UUID. We'll set the date to now. and we'll set the product to be the string that we've passed into this method. Incidentally, that product string will come from a post request that will be handled by the REST controller that we'll add in the next step. So now we have a complete order object. We can invoke the Rabbit template convert and send method. So let's do that now. So we need to pass in the queue that we defined in config. So that will be RabbitMQ config queue, and also the order that we've just built. And just so that we can see what's going on when the app is running, we're going to log out that order. Just with a string, say, sending order, and attach the order. Now we can do that because remember when we defined the order object originally, that has the toString annotation on it, so we can just log out the order and it will make sense. It won't just point to a memory location. Okay, so that's all we need for the publisher class right now. We now need to build the REST controller that will handle post requests and send the product string to this send order method that we've just built. So we'll need a controller package, and in there we'll need a class order controller. Now we know that this is a REST controller, and the endpoint is going to be /orders, I think. So that will be localhost port 8080 /orders. So first thing we need to do, we need to inject the order publisher that we just created, and we'll make use of Lombok again with a required args constructor. So in this class, we only need one method, and this is going to return response entity of string, and we can just call it create order. And we know that inside the request body, there's just going to be the product, which is a string. So inside this method, we're going to invoke the send order method of our order publisher. And we're going to send to it the product that's passed into here as a string. And then we can simply return the response entity 200 response just using the OK attribute, and we'll send a string order successfully placed. One last thing that I almost forgot. We need to add the post mapping annotation. We need no additional endpoint definition here, so it will listen for requests to the /orders endpoint that we've defined at a class level. Okay, that's everything we need for this publisher app. We've got the REST controller that we've just built to handle post requests sent to localhost 8080 /orders, and that will pass the product string to our order publisher class, which we built a few moments ago, where we construct a full order object by adding a unique ID and the date, and that order is then converted to JSON and sent to RabbitMQ using the built-in convert and send method. So we're now at a point where we can run the app and send a request to see what happens in the Rabbit UI. So I'm going to compile this to a jar and run that rather than run it within IntelliJ, because I've been having problems recently with Lombok and IntelliJ not playing nicely together. So I'm just going to move over to a terminal I've got open at the right directory. Okay, so that's built okay. We can now run the app. Now you can see the Rabbit Publisher application has started and it's running on port port 8080. Okay, I've actually stopped the publisher service and rearranged the screen a little bit to help demo what happens when we're publishing to the RabbitMQ, and also to demonstrate how to get Rabbit running in Docker in case that's been shut down for some reason. So to do that, remember the command. So this is the command that we used earlier to start the Rabbit Docker container. So it was in the installing RabbitMQ instructions, and it's exactly the same as this, except I took out the IT flag and I replaced it with the -D flag so that the container runs in detached mode. So let's run that, and just to be sure that it's running, we can docker ps, so there we can see our RabbitMQ container is running. So the next thing we're going to do is log into the RabbitMQ UI. So the username is guest and the password is also guest. So the first thing you see, we get the UI open at the overview tab, and we can see that we have 0 connections, 0 channels, 0 queues. So let's start our publisher app. Okay, so we have the app up and running. And now in this separate terminal window, I'm going to send a curl command, which will send a post request to the endpoint that we've defined in our publisher application. And then we can see what happens after that. So here you can see the curl command. We're sending it to localhost 8080/orders. Content type is plain text. And the request body is going to contain just this string, product1. So I've sent that request, and you can see immediately we get back the order successfully placed success message, and in the terminal logs for our publisher service we can see that we've sent an order with the ID there and product1, which was what we had in the request body here, and there's a date. And I can also see things happening in RabbitMQ. So we can see we now have 1 connection, we have 1 channel, and we have 1 queue. And we can see stuff happening in these graphs here. So this is the total number of queued messages. So we now have 1 queued message, and this is the rate of messages that have arrived. So that will keep going up and down, but this will stay at 1 because we have 1 message in our queue. And if we click on the queues and streams tab and open up the order queue, we can scroll down to get messages, and we can get the message, and we can inspect the payload from that message. So this is what arrived in our RabbitMQ order queue. So with an ID of 1288 blah blah blah. So you can see that that is the same as the ID that was logged by our publisher service. Product 1 is the actual request body that we sent, and the date, well, the date in the logs has been converted, so we can't actually see that that's the same, but everything else is exactly the same. And we can send another message. We just need to give it a different request body. So there we can see product 2 has already been logged out. If I go back to the overview tab, we can see we now have 2 messages. So another message has arrived. We can see from this graph here that the rate changed, and we can see that we've now gone up to the level of 2 messages, and we can see here there are 2 messages. And if I go into queues and streams, if I change that to 2, I can get both messages at once. So there's the first message that came in, and there's the second message. So I'll just send one more just for good measure. There we go, and we can see the same thing. Let's see what happens if I change that to a 3 straight away. There we go. We've got all 3 messages. So yeah, this is clearly a very small example, and I'm sure you can probably imagine in a production environment, in a real app, this UI will be a lot busier than this. There'll be lots of messages coming in. The rate will be a lot greater than it is here. But this just gives you an idea how Rabbit works and what the UI looks like. So I think we've made good progress. We've got Rabbit running locally in a Docker container. We've built our publisher and had that running locally, and it's been able to populate our queue. So at the moment, we've got 3 messages on the queue, but we don't have anything consuming those messages. So that's the next thing we need to do. We need to build our consumer application, and that's what we'll do next. To create our consumer, which broadly represents the warehouse management system. And here's another Spring Boot app. We are back in Spring Initializer. The setup is almost exactly the same as we defined for the Publisher app. We've got the same dependencies, Java 17, packaged as a jar using Maven and Spring Boot 3.4.4. The only difference is that this is a Rabbit consumer rather than a Rabbit publisher. So with those things set, we just click Generate and download the project files. Okay, if you want to carry on following along, you'll need to unzip the project that you just downloaded from Spring Initializer, which is what I've done here, and I've got it open in IntelliJ. You can see Rabbit Consumer. You can open it in your favorite IDE or editor. It doesn't have to be IntelliJ. And then on the right-hand side of the screen here, I've got still open the Rabbit Publisher application that we've already built, and we've seen that running and publishing messages to Rabbit. So concentrating on the consumer, remember that we plan to run the producer and the consumer apps at the same time. So we need to assign a different port number to our consumer. So let's open up application properties, and we can just add in server dot port, and we'll make it 8081 because the default port is 8080, and that's what our publisher will be running on. So from here on in, for the consumer, we're going to follow essentially the same process as we did for the publisher. So the first thing we need to do is create the order model. Now the order is identical to the publisher, which kind of makes sense because it defines what is essentially the same object. The publisher creates and sends a message to Rabbit with the payload that contains the order object. And then our consumer will retrieve that message from Rabbit. So we can largely copy across the order model from the publisher into our consumer. So let's create a model package. And in there we'll create our order class. Okay, next we need to define the RabbitMQ config. So let's create the config package first off. And in there we need the new class, which we'll call again RabbitMQ config. So let's have a look at what that class looked like in the publisher. Let's first of all take a look at the beans that we were creating in this configuration file. First one was the queue, and we don't need to include this in the consumer. I won't go into more detail on that here. You'll see why in a moment. So the template, which is this bean down at the bottom, we don't need that one in the consumer either because templates are something that are specific to Rabbit publishers. Now the message converter, we will need this in our consumer because the message will be read from the queue as JSON because that's the way it's stored within the message payload. And then we need to convert that into a Java object so we can define exactly the same message converter that we used in the producer and copy that across. Okay, so I think that's all we need as far as the methods are concerned. What about this constant that we defined in the publisher? I think it's probably a good idea to include that in our consumer. It is a form of config after all, and we're going to use it in our consumer application. So let's copy that across. And that's it. We don't need to configure anything else for this basic consumer. Okay, now we need to define a class that will consume the order messages from RabbitMQ. This is going to be a service, so we'll create a service package. And within there, we'll create the class that we're going to call order consumer. And we need to annotate it with a service annotation. And we just need one method in here that's not going to return anything, and we're just going to call it process order, and as an argument it will take an order object. So we just think for a moment here about what this consumer app represents. So if you remember the diagram from the introduction, this app is a representation of the warehouse management system. So we've called this method process order because you could imagine this being the first step in doing just that, i.e. processing the order as part of the warehouse fulfillment process. Now, in reality, our app will do nothing more than print the details of the order to the screen, but you get the idea. So let's just implement that. So we can print out a message, something like processing order, and then just log out the order. So one last thing that we need to do is to annotate this method with RabbitListener with a parameter that defines the queue that we want this method to listen to. So this is where we can make use of the config value that we defined in our config file. Now, this annotation achieves two things. First off, it defines the queue that this method is going to listen to. So that explains why we didn't need to include any queue config in the RabbitMQ config file. And also, because this is here, Spring will extract the payload from any messages published to the queue that's defined here. It will convert them using the message converter that we defined in the config file, and then it will pass the resulting object into this method as an argument. So that's where this comes from. We get this passed in by Spring because we've added the @RabbitListener annotation. So that is about it for our order consumer class, and actually for the whole of our consumer application. Right, well, we've finished with the code for now, so I've rearranged my screen a little to make it easier to see what's going on as we publish and consume messages. So on the screen now we have, on this left-hand portion, this is the RabbitMQ UI, and you can see we've got 3 messages in it, just as we left it after we were testing the publisher earlier on. And the right-hand panel at the top, this is the publisher jar running, and then this middle panel is ready to run the consumer application. I compiled the code that we completed just now into a jar, and that's ready to run in a moment. And then I've got an empty terminal window here. I'm going to run the curl commands to send the post requests to the publisher endpoint. So we've got the 3 messages that we have in the Rabbit UI. It doesn't matter that when we published those messages, the consumer wasn't running. That's evidence of the decoupled nature of the way that this is put together and the asynchronous nature of the communication. The fact that the consumer is down is essentially irrelevant to the publisher. It can just carry on publishing to the queue. So let's see what happens if we now start the consumer. So they can see as soon as the consumer spins up, it consumes the 3 messages that are already on the queue, because the count of messages has reduced from 3 down to 0 because they're no longer in the queue because they've been consumed. Now let's see what happens when we send a message with both the publisher and the consumer up and running. So I'm sending the curl command, which will send the post request to localhost 8080/orders, just with the string product4 in the body. So we'll send that. And we can see immediately product4 appears in the publisher terminal logs, and product4 appears in the consumer terminal logs. And if we just give the UI a moment to catch up, we can see that the rate has increased there. The count of messages doesn't increase because it was published and immediately consumed. So it's not sitting on the queue, but we can see that something happened because of the spike in the rate graph just there. Okay, what will happen if the publisher is down and the consumer is still running? Let's see what happens in that scenario. So to demo that, I'm first of all going to close down the consumer so that it doesn't consume the messages immediately that they're published. I'm going to publish some new messages. So we'll publish number 5, number 6, and number 7. So we've published those messages and we'll see them. You can see the count increasing in the Rabbit UI. Just give that a moment to spin up to 3. Okay, so we have 3 messages in there. I'm now going to shut down the publisher and start the consumer. So as soon as I start the consumer, you can probably guess what's going to happen. So there you go. As soon as the consumer spins up, it consumes the message containing product 5, product 6, and product 7. So more evidence of the decoupled nature of this application and the asynchronous nature of the communication. It doesn't matter that the publisher is down. It had already sent the messages, they were sat on the queue. As soon as the consumer started up, it consumed the messages that were already there. So I think that concludes the first part of this video. So far, we've learned how to run RabbitMQ in a Docker container, how to build a simple publisher, connect it to Rabbit and send messages to the queue, and we've also built a simple consumer, connected that to Rabbit also, and received messages from the queue. Time for a bit more theory. Remember this diagram where I introduced RabbitMQ just as a kind of black box and promised that we would take a look inside later on? Well, now is later on. The time has come to take a peek inside RabbitMQ. You may also remember this page from the introduction. As you know, AMQP is a network protocol. So let's read this brief introduction that explains at a high level what it seeks to achieve. The AMQP model has the following view of the world. Messages are published to exchanges, which are often compared to post offices or mailboxes. Exchanges then distribute copies of those messages to queues using rules called bindings. So let's examine some of the terminology you can see in italics here. First off, queues. We've come across those already, and hopefully you're pretty comfortable with that concept. We also have exchanges and bindings. Well, these will become clear during this next section, so don't worry too much about what that means at the moment. And then here we've got this image which gives us a visual representation of that AMQP view of the world. So let's examine the flow. So when a publisher sends a message to RabbitMQ, it's actually published onto an exchange, and from there it's then routed into the queue. Now if we think back to the publisher that we've just built, there was no mention of an exchange. So if we have a look here, so this is the RabbitMQ config class in the Rabbit publisher that we've just built. This is on GitHub, by the way. There's a link to the repo in the description. And in this config file, we've only defined a queue here. There's no mention in there of an exchange. And if we have a look at the order publisher, when we invoke the Rabbit template convert and send method, it looks like we're just passing the order directly to the queue. Again, there's no mention of an exchange. So what's going on there? Well, let's do another quick dive into the docs. Well, AMQP and by extension RabbitMQ has the concept of a default exchange, and you can see that mentioned in the menu here. So let's have a look what it says about default exchanges. Well, the default exchange is a direct exchange. Now don't worry too much about that, we're going to explore direct exchanges in a little while. It's a direct exchange with no name, so effectively an empty string, that is pre-declared by the broker. And it has one special property that makes it very useful for simple applications, so like the one that we've just built. Every queue that's created is automatically bound to the default exchange with a routing key which is the same as the queue name. Again, don't worry about the terminology here, this will all come clear. Essentially what this is telling us is that when no exchange is defined, like in our publisher, a default exchange is automatically created and messages are sent there. And this default exchange automatically routes messages to the queue that's named in the Rabbit template convert and send method. So if we just take a look at the final sentence in this second paragraph, in other words, the default exchange makes it seem like it's possible to deliver messages directly to queues, even though that is not technically what is happening. So our publisher actually is publishing to an exchange, we just didn't realize it. Okay, just quickly want to go back to some of the terminology that we skipped over. Right, it says the default exchange is a direct exchange. What does that mean? And what about queues being bound to exchanges with a routing key? Well, to answer these questions, let's get back to some practicalities. We're going to adapt our existing publisher application to use a direct exchange. Firstly, we're going to use the same queue that we've already got, and then we're going to add an additional queue. And through that, we will explore how a direct exchange works by binding the exchange to a queue using a routing key. Okay, we're back in our publisher app in the editor with the RabbitMQ config class open. So since we're going to explicitly use a direct exchange, we need to add a method to define one in this config file. So this method will create a bean and it will return a direct exchange. And if I open up this import section here, you can see that that direct exchange has been imported from the AMQP core library. And we'll call this method simply exchange. It takes no arguments, and we will return a new direct exchange and pass in a string that will name the exchange. So we're going to call it order exchange. And actually, let's extract this as a constant that we'll simply call exchange. Okay, so now we have a queue, which we had previously defined, and we have an exchange, which we've just added. We now need to bind those two things together by defining a method that, again, will be a bean. And it will return a binding, which we need to import. And we'll just call this method binding. And it needs to take the queue and the direct exchange as arguments. And we're going to return a binding builder, which binds the queue to the exchange with the routing key, which we're going to define as standard order. So again, let's extract this as a constant that we'll call routing key. And the only other change that we need to make is in the order publisher class. Right now, when we invoke Rabbit templates convert and send method, we only pass two arguments, the queue and the order object. Well, we need to change that so that we actually pass three arguments. So that will be the exchange and the routing key and the order object. So this can be exchange, routing key, and we can leave the order as it is because nothing needs to change there. And that's it. They're all the changes needed to implement a direct exchange and get it to route messages containing the standard order routing key to our order queue. So let's recompile the publisher application. Now I'm going to open up the Rabbit UI and we'll log in. Let's run this publisher application. And let's send a message. Now if we look at the Rabbit UI and open up the Exchanges tab, we can see that we have here our direct exchange. And if we click on that to open it up, and scroll down, we've got this bindings panel, which is open. And we can see the name of the queue in this exchange is bound to it using the routing key standard order. And if we look in the queues tab, open up the order queue, we also have a bindings panel here. And here we can see that this queue is bound to the order exchange with the routing key standing order. If we start up the consumer, remember we've changed nothing here. The consumer simply consumes from a specific queue. So from this queue called order queue. And it doesn't really care how messages are being routed into that queue. So if I start this up, we can see that the message is consumed in exactly the same way that we've seen many times before. So this is the message that we just dropped onto the queue a moment ago. So that's how easy it is to implement a direct exchange. Now let's investigate how we can use a direct exchange with more than one queue. So imagine this scenario. We are now offering a premium next day delivery service from our warehouse. So orders need to include a property that indicates whether it's a premium or a standard order. Premium orders will be sent to a new premium order queue, and non-premium orders will continue to be sent to the existing queue. And the existing queue will be renamed to standard order queue. So we'll need to make some changes to our publisher service to accommodate this scenario. Now, to avoid you having to watch me type very slowly, I've already made those changes, and we're just going to take a look at them now. I'm going to demo the changes in this commit panel so that we can have a side-by-side view of the before and after code. So first off, we'll look at the RabbitMQ config file. So what are the changes that we've made here? Well, first thing to mention is I've defined a new premium order queue, and the name of the queue has been defined as a constant here. And I've renamed what was previously just called order queue. I've renamed that to standard order queue, and I've renamed the constant to standard queue, and I've also changed the text value that constant refers to. You can see there's no change to the definition of the exchange. That remains exactly as it was. But I have added an additional binding because we now have two queues that are bound to the same exchange. So the previous binding, which the method was just called binding, I've changed that to be standard binding. And I've set up a new method which creates a bean for a premium binding. So that will bind the premium queue to the same exchange. Now note that because we are generating two beans based on this same queue, we need to add the qualifier annotation so that Spring can differentiate between the two queues. And note that the name that we give to the qualifier is the same as the name of the method that generates the queue bean. So our standard order queue has the name standard order queue, which is that method name, and our premium queue is bound to the exchange using this qualifier annotation with premium order queue. And each binding needs its own routing key. What was just called routing key, I've renamed it standard routing key because that relates to what is now the standard order queue. And for premium orders, I've defined this premium routing key. Both of these are constants, which you can see here. So scrolling down to the remaining methods, there's no change to the message converter and no change to the AMQP template method. So that's everything for the RabbitMQ config file. Now the post request that's sent from the storefront will now need to include an indication of the type of order, so standard or premium. So the request body can no longer be simply a string like it used to be. It will now be a JSON object. So we've defined here an order request DTO. This defines the shape of the JSON object that will be in the request body. We can define the order type, which will just be a string. That will be either standard or premium. And we've got the product, which is the same string as it was previously. Now, if we look at the order controller, this needs to cater for the changes that we're making to the request body. So the create order method parameter is now an order request instead of just a string. And that same object that's passed in here is sent on to the order publisher send order method. So that brings us on to the order publisher. In here, the send order method now receives the order request instead of just a string like it used to. And inside the method, the order.setProduct method now needs to extract the product from the order request instead of just the product that was passed in previously. Then we extract the order type, and based on what it contains, define a routing key, which takes the appropriate constant value, either a premium routing key or a standard routing key. And that routing key is then one of the three arguments that are passed to Rabbit template convert and send method. So we have the exchange, we have the routing key that we've just defined here, and we have the order object. So this way we can dynamically generate the routing key based on the type of order and route messages to the appropriate queue. Okay, so they are all of the changes that we need to make to accommodate this changed scenario. So after making those changes to the publisher application, I've compiled the app and I've rearranged my screen so that we can see what happens when we send some messages. So in the left-hand side of the screen, you can see we've got the RabbitMQ UI up and running. In this window, I'm going to start the publisher application. So there we have the publisher up and running. And in this window, I'm going to send some messages with some curl commands. You can see that I've had to slightly change the format of the curl commands because the request body now contains a JSON object, not just a string. So we have product and the product string, and order type for this particular one is standard. So let's send that message. We can see the message has been sent there. And if we give the Rabbit UI a moment, there we go. So you can see we've got one message being delivered there. So this message, you can see the product is product 2 and the order type is premium. So I'm going to send that one. So as you can see in the publisher logs, that gets logged out there. And you can see in the Rabbit UI, we now have 2 messages. So let's inspect this UI a bit more closely. If we take a look at the Exchanges tab, you can see we now have our order exchange, which is a direct exchange. And if I open that up, we can see in the bindings panel that it's now bound to the premium order queue with the routing key premium order and to the standard order queue with the routing key standard order. So that's how we set up our publisher when we made those changes. And if we take a look in the queues tab, we can see we now have 2 queues. We have the premium order queue, which has 1 message in it, and we have the standard order queue, which has 1 message in it. So if I open those up, let's do the premium one first. We can look at, again, we've got the bindings panel here. So the premium order queue is bound to the order exchange with the routing key premium order, as you would expect. And go back to here and look at the standard order queue, the bindings there, it's bound again to the order exchange with the routing key standard order. Nothing surprising there. While we're in the standard queue, let's have a look at the message. So we can see that if we have a look at the ID there, AC715, that matches up with the first one, AC715, and the first one was a standard delivery. Take a quick look at the premium message and we can see what that message contains. So that was, the ID was 40B4, so that one, 40B4, and that was the second message, so product 2, which was order type premium. So that one's ended up in the premium order queue. So I can just send another message just to demo how this works. So I'll make this a premium message again. I'll just change the product to 3. So there we go, product 3 has been sent and we're in the premium order queue here. We can see something happening in the rate graph there, and there we've got another message has landed in our premium order queue. Just so that we're sure, we can look back at the standard order queue and we only have 1 message. So the messages are being delivered to the right queue depending on the routing key that was attached when the message was sent. Okay, so we've seen that the publisher can deliver messages to different queues. What about the consumer? Well, I don't intend to spin up any consumer app to consume these messages. Instead, what I want you to do is treat that as a project. See if you can make the necessary changes to the existing consumer so that it can consume from both queues and log the output, making it clear whether the order being logged is a standard or a premium order. You'll be happy to learn that we've reached the end of the video. We've covered a lot of ground. To begin with, we compared event-driven systems with the more traditional request-response systems that you're probably more used to. My hope there was to provide some context, some mental hooks on which you could hang the new concepts. We then learned how to get RabbitMQ running locally in a Docker container, and we connected a publisher to that local instance of Rabbit and sent messages to the queue that we were able to inspect in the Rabbit UI that was also running locally. Then we added a consumer to fetch messages from the queue. And we then learned that in truth, our publisher wasn't actually sending messages to the queue at all, but rather to an exchange. And the exchange was then sending the messages on to the queue. And we further learned that our exchange could actually connect to more than one queue. And then we dived into exchanges in more detail, exploring both default and direct exchanges. So what about next steps? If you haven't done it already, see if you can adapt the consumer to listen to the standard and premium queues and log out the messages, identifying the queue that the message came from. Other things that you could explore, there are different types of exchange that you could dig into. There are fan-out, topic and headers exchanges. Or you could perhaps look at some other concepts like acknowledgement of messages or dead letter queues. Once you start digging around the docs, you'll find a lot of areas to dip into. I hope that you now have a firmer understanding of RabbitMQ and its inner workings, and that you feel more confident about implementing it in Spring Boot applications. If you got some value from this video, then I would really appreciate a like, and please subscribe if you're interested in seeing similar content. If you have suggestions for anything else that you'd like to see a video about, then please let me know in the comments. So that's all for now. See you next time.